Hello, everyone, and welcome to the October 2014 Professor Messer Network Plus Study Group. This is our monthly get-together where it's become more than just a study group, hasn't it? It's become more of a pop quiz / study group. In the first hour today, I'll be asking you questions and you will be answering them online. I'll talk more about how you can do that in just a moment. And then we're also going to go through and take some phone calls after that in the after show. Thanks for joining. If you're watching this, you can watch it live on professormesser.com/live. You might be watching on the YouTube side. If you go to the Professor Messer website, there's also a live chat there. So I can watch all of the things you're typing in there, and questions and ideas and comments all come from there. And of course, I'll be able to talk to those as well. We do this every month. This is something we like to get together and just something I like to do to provide a little bit more feedback to you. You ask me questions throughout the month. You send me emails when you register for this event. You also send messages and questions in. And if you'd like to follow along with us today, we'll be glad to have you answer questions with us. This is something that's also supported by you as well. So I have, of course, all of my free Network Plus videos out on the internet. You can watch every minute of every video absolutely free. If you want to take videos with you offline, I also offer a set of those for sale as well. You can find out more about that at professormesser.com/download-network plus. And of course, if you'd like to follow along with things that I do during the study group days and hours, you can find me on professormesser.com/Twitter and professormesser.com/YouTube. Some people have said, I really don't have the money to buy the course. That's fine. You can watch it online for free. But if you would like to contribute and give back, I don't accept donations. But if you were to go to my YouTube channel and subscribe, or go to Twitter and follow what we're doing, that's always appreciated. There's quite a bit that we're going to do today. And if you want to follow along with what we are doing today, you can use the website socrative.com, where I will be asking the questions, and this will give you the opportunity to choose the right answer. And we'll get to see what everybody thinks of the answer that is there. You can go to socrative.com and choose that you are a student and go to the room called Professor Messer, all one word. If you have a mobile device, you'd like to do this in a mobile device instead of a separate window on your desktop or on your tablet, you can go get that app from Google Play, from the Apple App Store, from the Windows Store, and have that. You want to download the student version of Socrative, not the teacher version of Socrative. So that would give you an opportunity then to follow along, because I'm going to ask questions of you throughout this next hour. Here's the first question, in fact. So this will give you a chance to log into Socrative, give it a shot, see what you think of the interface. And it's going to ask questions of you like this one, which is, how long have you been studying for your Network Plus certification? And you'll have a number of options available: less than 3 months, 3 to 6 months, 6 to 9 months, 9 months to a year, over a year, or I already have my Network Plus certification. And on my side, what I get to do is see the results. So we'll be able to also see all of your results as you're answering these. Is it less than 3 months, 20%, 6 to 9 months, 40? A lot of you haven't even gotten in there yet to answer these questions. We can, as you're answering the questions, as you can see, you can interactively see the changes occur right here on the screen. So I'm going to ask you the questions about networking and the topics associated with the Network Plus certification. We'll see how well you know some of these things. I've tried not to make it too hard. Maybe I've stuck a little tricky question in there every once in a while. I try not to make them too difficult, because when you take your Network Plus certification exam, it's relatively straightforward. They're not really asking you a lot of trick questions. It's a very obvious question and a set of very obvious answers, or an answer popping out of the list that they have. The Network Plus certification, this came up this week, really, has been around for a while. There was a question on Reddit I was talking about or typing a reply to, I think it was this morning or last night, that had to do with the Network Plus certification itself. It's been around since, at least this version of it, called N10005, has been around since December 1st of 2011. So we know that CompTIA tends to go 3 years before they release a new version of a certification exam. 2011, 12, 13, 14, this would be the year then that we might expect a new version of the Network Plus certification. This is Nothing that they've announced yet, but certainly it seems to be that they're keeping this every 3-year pace. And some of the comments that we've seen CompTIA make in other places on Twitter, on Facebook, tend to point to more of the end of the year. Now, if you're studying for this one, that's okay. They usually have an overlap period of about 6 months. So when they release the new version, you can still take your old one, and you've got 6 months to study and finally take that old one, so you don't have to immediately transition into the new one. So don't feel that you shouldn't be taking this exam right now, because it will simply retire, but it's going to retire at least in 9 months from now or so. So you'll get plenty of ramp. Whatever that time frame is, you'll have plenty of time to do that. And for those of you that are studying for your exam, we can see most of the people commenting, 48% joining us today, less than 3 months you've been studying for your Network Plus certification. So a very large group of you are just getting into this. So don't worry about the exam going away. And even if you wanted to, when the exam changed, take the new version, they aren't completely changing everything in the exam. Networking technologies don't tend to change quite that quickly. There are, of course, new technologies on the exam, but things like Ethernet have been around for many, 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 many years. So you're not going to see Ethernet go away. It doesn't roll off the exam. And one nice thing about networking is you tend to see a lot of different things. You tend to see a lot of different technologies, and these technologies tend to stick around for a very long time. So generally the changes that you might expect are things that are incremental changes. So there's never an enormous amount of material that would be brand new. So that's a good idea anyway of what you might expect on your Network Plus certification. The changes that happen on this exam were things like virtual networking, the OSI model, has a lot more information about the OSI model, security. So in the last 3 years, a number of new technologies have really emerged. There's been a lot more IPv6. There's certainly been a lot more virtualization, and software-defined networking is becoming a thing. So you'll probably see things like that. And as soon as CompTIA releases those objectives, I'll certainly have that material for you, and we'll go through it with a fine-tooth comb. I'll tell you exactly what has changed between those versions. Well, let's now jump into questions. I have plenty of questions for you today. I've gone through and created these pop quiz questions. These are brand new questions I created this week based on the questions you were sending to me. So let's start this. I've got my very first question of the day, which is, which of these is an RFC 1918 address? As some of you have been on my study groups before know, I tend to ask questions that have multiple steps inside of them. So you first have to know what an RFC 1918 address is, and then I have options for you, such as 11.92.168.7. Is it 172.16.22.23? Is it 1.10.22.77? Or is it 168.192.55.2? Boy, we really showed up with a lot of numbers first thing. So this is one where you'll notice in your socrative front end, you can actually choose more than one. Now, in this particular case, when I'm saying that there's no number you should choose, there's only one right answer with this. So we want to look at these very carefully. First, understand what is an RFC 1918 address for those pieces of it. And then we want to be able to break them down a little better. Don't answer in the chat room, of course, but feel free to go out to Socrative and be able to type in all of the things that you see on the screen. Go to the student login and use the Professor Messer name for the room name. It might also ask you for your name, and you can put anything in there. We're not tracking this by you for what those things are associated with it. We're really just going through the list and getting an idea of some of the things that you're working on. One of the things I love about these particular questions and what we're doing with them is I'm not really trying to fool you, but I think this two-step process gets us thinking about what the answer could possibly be. And if we look at what we've answered so far, this is a good example. We're sort of all over the place. If we had to go with the current majority, not even a majority, we're at 50% exactly. Half of you said 172.16, 22.23. But a large number of you said 168, 192, 55.2. And a number of you said 1.10.22.77. Interestingly, nobody said 11.92.168.7. So this is where you get into a bit of a challenge trying to figure out what are these numbers, especially with IP addressing. There's so much subnetting that gets thrown at us in this exam, but very important aspect of what we're talking about in the Network Plus exam is the difference between a public address and a private address. So if we were to break this down a bit, these are what we call RFC 1918. These are requests for comment, and they are a set of standards on the internet that are associated with many, many different topics. The one that is 1918 is something that we sometimes rarely call it that, but you'll see people say, what's the 1918 address of that? We're really talking about these private addresses that would be assigned on the inside of your network. And they are what we've done because there is a large number of IPv4 addresses out there. We needed some way to limit the utilization of those addresses. We might have some companies that have thousands, tens of thousands, or even hundreds of thousands of devices on the inside of their network. And if we were to give them all public IP addresses, we would very quickly go through those IPv4 addresses. So to resolve this, we create a set of addresses that would never be routed on the internet. These are private addresses you would only use on the inside of your network. In fact, the only way you could possibly route somebody out to the internet is to do a network address translation so that it had a public address on the outside. And that's how a lot of companies will do that. I think last month we did a couple of questions on NAT. So, and of course, my videos, if you want to go back and look at those NAT videos, you can. The private address of 1918 is what we're talking about then. These are all the private addresses we would assign that are not routable on the internet. And you can see there are a series of ranges that have been assigned by this. And if we look, the range that begins with 10.0.0.0 through 10.255.255.255. So if we think about this, anything that starts with 10 is a private address. It's an RFC 1918 address. Another range is 172.16.0.0 through 172.31.255.255. You can think of these as having multiple Class B addresses available, even though technically the subnet mask on this is a /12, interestingly enough. But just look at the number range here, 172.16 through 172.31. So if anything starts with those numbers, it's an RFC 1918, and 192.168.0.0 through 192.168.255.255. That gives you a big chunk of Class Cs if you wanted to subnet it out that way. So that is where we get those numbers from. So if we go back and look at the answers for this one, it's certainly not the 11.192. That doesn't match anything that was in our list here. 10. It's got to at least start with a 10, a 172, and a 192. And in some cases, it's got to be a very specific range within that. 11 doesn't start with any of those. 172, there's 172.16.22.23. Well, that fits perfectly into the 172.16 range. So that does indeed qualify as an RFC 19 address. Do any of these others qualify? 1.10, well, the 10 is in there, but it starts with a 1. The 1 dot address is not a private address. That is indeed a public address that you have out there. And I mixed this one up. I switched it around because it has sort of a rhyming in our head. Whenever we're connecting to a home network, certainly in a number of corporate networks, you're connecting to 192.168.something.something. So I mixed them up on you. I said 168.192. The numbers are the same. Yes, but I reversed them. It must start with 192.168. So D would not be correct either. Your correct response here was indeed B, 172.16.22.23. So keep that in mind. You may be given a list of these on your certification exam to be able to answer. One of the things about IP addresses, of course, is that there can be a lot of calculations from decimal to binary and binary to decimal. And especially if you're planning to do any type of subnetting with anything on the exam, you may be in a position where you will want to do some of these calculations. And you should certainly understand how to do that. I think it helps you understand how subnetting works, even if you use a number of shortcuts to finally do your subnetting. So the question I have for you, and you may want to get a pencil, a sheet of paper, something to write on to be able to work this out, because I have a binary conversion question for you, and that is, what is decimal 154 if you were to convert it to binary? So this will be the craziest sounding set of answers you might go through. Is it 100111010? Is it 000? I'm not even going to say these. It's ridiculous. Is it this grouping of ones and zeros? Is it this grouping of ones and zeros? Is it that grouping of ones and zeros? Or is it the other grouping of ones and zeros? We want to be able to do the calculation with these and get them absolutely right. That's one of the challenges you're going to have with binary to decimal. It's a lot of ones, it's a lot of zeros, it's a lot of stuff to keep track of. And if you ever start looking at it, there is a lot of detail in here that you're going to want to go through. Now, don't answer this in the chat room. You absolutely want to go out and to the socrative page to be able to look at these possible answers here. You know, binary is one of those things that I think when you start working with it, it's a little intimidating at first, but I have a great video on binary math that takes you through the process of creating a table, and very quickly you're able to calculate the differences as when you move between a decimal to binary or binary to decimal. So it's one of those things that you may want to have a look at that video to be able to do that. There is a lot that we go through when we're doing these conversions. There's a lot of writing down, and when you go to take your exam, they will give you something to write on. My local testing place, they used to give me paper. They don't give paper anymore. Now pretty much everybody has gone to a whiteboard or some type of glossy paper that you can use whiteboard markers on. One of the problems I have, especially on an exam where you're doing a lot of calculations, is they usually give you one of these big fat whiteboard markers. You've got an 8.5 by 11 piece of not paper, but this glossy paper, this laminated paper. And if you try to even write 2 lines, you've now used up all your space. I will usually bring my own very thin pointed whiteboard marker. So it's designed to write in those tiny little areas, because if I'm taking an exam that wants me to do a lot of subnetting, I write out the entire table right there so that I'm not able to make any mistakes. During an exam, there's a lot of pressure. You're nervous. There's adrenaline. You're reading the screen and you can't understand what it says, even though it's written in plain English. There's just it's a time when you don't want to be able to make mistakes. And subnetting for me is something I make a lot of great mistakes when I'm trying to calculate things out in real time. So before the exam starts, I'll usually write out everything and I'll just have it ready to go. It's my little cheat sheet. Well, if they give me the big fat marker, I can't do that. Now, if we were to do the calculations, we're sort of all over the place again. 66% of you said it was the first set of zeros and ones. Only 3% said it was B. Some of you said it was C. Some of you said it was D. So how do we even go through this process of converting from a decimal to a binary? Well, it's easier than you might think. Let's break it down into its individual steps. And I go through this exact same format in my video. This is one where I take any number, take 154, which is the question we're dealing with in this particular example. So we don't know, if we were to write down in binary what this is, we don't know what that is. But what we do know is we can create a binary conversion chart. And the way you do that is you start on the far right with the number 1 and you double it, and you put a 2 next to that, and you double it, and you put a 4 next to that, and you double it, and you put an 8 next to that, and then a 16, 32, 64, 128. That is your conversion chart. That's exactly how binary works. Technically, it's 2 to the first, 2 to the 0, to the first, to the second, to the third. If you have it all the way out, calculating that way, that's what they turn out to be. What you're trying to do is find the combination of these numbers that adds up to 154. That's it. So there's only one way to do it, which is the beauty of binary. You can take a certain number of these, combine them together, and they all add up to 154. That's it. That's how hard binary conversions are. So we've got 154 decimal down. Let's start filling them out, and we'll start at the left side. You can, of course, start at either side. It's much easier to start the largest number. Well, we know that 128 is less than 154, so we're going to use 128. So we're up to 128 so far. So we've got another one to go through, 64. So if we added 128 plus 64, would that be less than or equal to 154? Well, it would be bigger than 154, so we wouldn't use it at all. It's not less than or equal, so we don't even include the 64. All right, if we added then 128 and 32, That's 160. That's still bigger than 154. We just keep going down this, and every time we can keep adding up along the way, like adding 128 and 16, that's 144. That's less than 154. So we're going to put a 16 down there, and we're going to keep going all the way through this process. I'm just going to keep clicking my button here to go finish up all the way through the process, because there's only one combination of these things that absolutely works. So if we get all of these in place, we know that we've got 128 plus 16 plus 8 plus 2 equals 154. So at every place where we put a yes, that we indeed want to use that number and add it up, we're going to put a 1. Every place where it was greater than that particular number, we put a 0. And you can see we filled in all the 1001, 1010. That is the answer for this particular question. So that is what we do with that number. If now we go back and look and see how we did, we know it's 1001, 1010. That's 68% of you that answered that. You were right on the money. You were absolutely correct. I tried to change it up and do different numbers here, but certainly that is one of those times where you go through the process and you're trying to figure out which one of these is really the best one to use. It's simple calculation. And one of the great things about decimal to binary is that it's always, always, always going to be exactly the same thing every time. We can't go wrong with binary. Otherwise, our computers wouldn't work very well, I suppose. Well, if you were to take these numbers, in fact, and put them into a chart, one of the fast things you can do, and there's some very easy ways when you start doing subnetting to make this faster, is to memorize this table where you're looking at the exponents of the 2. This is obviously binary. It's either a 0 or a 1. You have a choice of 2. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. Notice it's the same set that we were using on our conversion chart. That's where those numbers come from. And you can continue the conversion chart out. 2 to the 8th is 256. 2 to the 9th is 512. 2 to the 10th, 1024. Another one of those things that you're able to write down when you go in that might help you with the subnetting part of your exam. All right, so we've done a little binary. We've gone through the process of thinking about how these things work. The next question I have for you would be don't answer in the chat room, but here's a question for you. Which routing protocol has a logical network backbone grouping called Area 0? That sounds suspicious. Area 0. The government facility Area 0. Now, this would be something else. This is a routing protocol. You got a number of options here. One of your options is BGP, which is A. Your option B would be OSPF. Your option C would be RIP, and your option D would be static. One of these routing protocols uses this logical network backbone. It's called Area 0. So you really need to understand very broadly how a number of these routing protocols operate. And they all use a different methodology. They all use different terms. And if you get into networking, you would absolutely be in the case where you are using one or many of these particular protocols. It's unusual for me to walk in somewhere and they're using one thing. They're usually using a lot of different kinds of technologies all at the same time. So that's where you get into really trying to understand, where do I get into this and get the specifics I need for this routing protocol. So this is a very good example of why we would want to understand how these work, because this concept of Area 0 is actually pretty important. And when you get past your Network Plus, you're working on your next set of networking certifications, you will certainly be asked some of these things. You'll need to know a lot about this particular protocol. So it's very important that you go through that list of protocols that I have in my videos and understand at a very high level how they operate. You will certainly be getting into lower levels of how they operate later on with what you're doing. So make sure you go to the socrative.com website or use your Socrative app, and we are going to see how we've answered this one. We've had a number of you answer with this one, and again, we're sort of all over the place. We certainly have a majority here with the OSPF, but is that really the correct answer? Because 13% of us said BGP, 13% of us said RIP, and 16% said static. So there's a number of different things to be able to work and understand how these things are operating. Let's break down this particular routing protocol and how it works. There is a number of things we can look at. The answer in this particular case is one called Open Shortest Path First. This is something that generally is done on the inside of your network. It's not something used across the internet to connect sites. And because of that, we call this an interior gateway protocol. This is something that is a link state protocol. It's important to know the differences between these protocols and how they operate. It's called link state because we're checking to see, is there a link between these sites? And if there is, how much does it cost to go over that link? Think of it as a bridge. You're paying a toll. There's a lot of different bridges. You might be able to take one bridge and go across the bay to a location, or you could take a second bridge and go to the same location. But which one do you take? You take the one that's going to be cheaper. And if that's the particular case, that's how OSPF works, you're going to use the one that has the less cost associated with it. I like that we use those terms. That way we're able to really break it down and understand this. OSPF looks at a number of different things to determine what that cost is. Because if you're looking at the two bridges, maybe this bridge is cheaper, but maybe it's one that a lot more people use. It's more congested. It's going to go slower. So maybe I want to pay a little more to go across the bridge, but it's going to be faster in the end. I'm going to get there in a much faster time frame. OSPF's pretty smart about some of these things. It understands at least the throughput of the network. It understands the reliability and the round trip time with that. Very useful to have that. Number of OSPF implementations can do load balancing even better. So if the bridges are pretty much the same, let's send traffic across both of the bridges to be able to do that. Crazy idea. This is a dynamic protocol, of course. This is one that automatically adjusts depending on how the network is performing or how it's configured at any particular time. If you have a problem, they have to shut down the bridge to do maintenance. You want your dynamic routing protocol to recognize the bridge is shut down and adjust everybody over to go across the other link. That's one of the things that is important. Otherwise, if it's not a dynamic routing protocol, it's a static routing protocol, you would manually have to go into a configuration of a router and make those changes yourself. It's not something you can really do at a moment's notice. So generally, these dynamic routing protocols are really useful to be able to do that. And OSPF is one that really does allow us that functionality. I mentioned that area 0 is so important. The basic foundation, the backbone of an OSPF network is an OSPF area 0. You set up these logical areas in your network. A lot of networks are just one big area 0. But sometimes you have a network that is so large. You have an East Coast, you have a West Coast, you have a European region, you have an Asia Pacific region, and you may want to have all of those in their own little routed worlds. So you might set up different areas for them. This autonomous system of numbering is something based on how you set it up. You can logically set it up any way you'd like. Technically, you could set up different areas for every floor of a building. That's probably not how OSPF was designed to work. You'd be crazy to do that, really. Make it much more complicated than yourself, which is probably why most people just have one big area. But OSPF can be extremely flexible. You can have extremely complex networks that are all routed dynamically and work extremely well using this OSPF set of protocols. So when you start getting into doing dynamic routing in a large organization, you may come across OSPF. Although it's very complex and can be difficult to learn the nuances of it, it's an extremely effective protocol to use. And I think that's one of the reasons that it has been around for so long, and we've continued to support it in all of our devices that we use. Well, I want to take a moment, and somebody was mentioning this in the chat room before we got started, is that there are a number of resources I make available to you absolutely free for Network Plus, but I also have a number of things that you can buy from the website, and every dollar you spend goes to supporting keeping the website running. And some of them are, I think, actually quite good, like this Network Plus study guide, something I created myself. I took all the information from all my videos, and I've effectively created these course notes. I've taken all of the important information that you might want to run into, and those course notes are available in an electronic form in a PDF document that you can download immediately for $10. If you'd like to know more about this, you can go to professormesser.com/netsg. And of course, I have links at the top of the page and on the video index page as well to see those. But it's got all of these things we've been talking about so far. In fact, there's my binary conversion chart just stuck right there in the study guide. I've got there's my subnet classes. There's the RFC 1918. We just talked about those coming right from the videos. I'll just scroll through a few of those. All the ports and protocols you need to know about. Look, there's our link state routing protocols, the OSPF. I'm talking about the details of an interior gateway and exterior gateway. These are all the things in the video. And if you're like me and maybe note-taking is not your forte, I have just everything available for you. I've tried to take everything pertinent that you would need to know for the exam, or at least remind yourself for the exam, and I put them into this study guide. So a lot of people have said, what does it look like? Is it something I can use? Well, maybe this can give you an idea of just some of the information that's in the study guide. And it's available for you to see on the page, which is at professormesser.com/netsg. I have some screenshots and other things there as well you can go through. Well, there's plenty more questions to go through, so I've got another one for you. We're already halfway through the first hour. I can't believe it. And I'm always bad about timing, aren't I, with these? We tend to go always a little bit long. That's fine with me, I guess. We can go that. Let's go to the next question, which is, what protocol does 802.1d use to prevent loops in a network? Again, these two-step protocols to be able to answer these particular questions. I have to know these steps. I have to know what 802.1d is, and then I have to know which protocol is used by 802.1d. So we have a number of examples. If you go out to socrative.com and go to the Professor Messer page, you can go through that piece. The possible answers are SNMP, SSH, SSL, BPDU, VLAN. So you've got a number of very interesting protocols there. Which one does 802.1d use? And this particular question, I felt bad. I kind of gave you some hints. And if you parse out the question, it might lead you down a particular path. If I was being really, really obscure today, I would just say, what protocol does 802.1d use? And then it's really up to you to figure out the details. You might be asked something that's specific on the exam. And this is an opportunity to learn here. I'm not trying to trick anybody with these particular questions. So feel free to go out to the Socrative website, have a look at the possible answers. And like many things, whenever I try to ask these questions, I'm not really trying to trick anyone, but I do like when we answer all over the place. I think the only opportunity you have to learn is when you get it wrong. Whenever I've really learned an operating system, or I've learned about networking, was when the operating system wasn't working or the network was not working. And you have to get in there and capture packets and go through the details and understand what's connected to what and understand the different layers. And after going through the troubleshooting process of seeing it break, then you have actually learned how it works under the surface. In our particular case, we're all over the place. We've got 40% have said SNMP, 6% said SSH, nobody said SSL. I've got 47% BPDU and 6% VLAN. So we've got quite a mixture of different options here. So which one of these is the protocol used in 802.1d? If we break it down, we're really talking, I told you in the question, this was to prevent loops. So that was your hint. Even if you didn't know what 802.1d was, you could at least understand that this was used to prevent loops. And that might tell you, oh, okay, this is how we prevent loops on a switch, because there's no mechanism in a switch to throw away packets that are looping around. Those packets will loop forever and ever and ever. They will never go away in a switch if we have a loop. It's a really bad thing if we have a loop. It's so easy to set up a loop on a switch. If you've ever been on a production network and you have accidentally brought it to its knees, yeah, that would be me. Everybody does this. Everybody has that moment where they plug in the wrong thing and they realize immediately, this was a really bad idea. Why did I just do that? And of course, your phone goes off. People come running into the room. What's going on really is not a place you want to be. So you might want to use something like 802.1d, which we call spanning tree. This is a technology that's been around for a very long time. Radia Perlman came up with this technology. It's used in practically everything we do these days. There's newer versions of spanning tree these days, rapid spanning tree and other mechanisms as well. But it's still the same idea, where the network is smart enough to figure out where a loop might exist, and it then stops the loop from occurring. You don't have to touch anything. You don't have to do anything. And if the network changes, if you have a switch that goes down and it reconfigures itself This spanning tree protocol also knows that a change occurred and it reconfigures itself to prevent any loops. Really, really useful to be able to have that there. Now, the spanning tree protocol itself, some people call it STP for the spanning tree protocol, uses a number of technologies, but it sends these messages back and forth between the switches, and the protocol used to send these messages back and forth is called a bridge protocol data unit, or BPDU. This bridge protocol data unit is what these switches are all talking to each other using. They all have to say their bridge language. Hey, bridge or switch. That's the same thing. A bridge is a switch. Hi, I wanted to see if there's any loops. Let me send you some information about myself. I'm going to send that to you with the BPDU protocol. The other switch says, well, let me tell you some information about myself, and I'll send that with the BPDU protocol. So it's not using FTP. It's not using HTTP. In fact, it's not using any of these that we saw, except for those of you that answered D for BPDU. You would be absolutely correct to be able to have that answer there. So it's not SNMP. SNMP is a simple network management protocol, and the name of it makes it sound like management. Well, that's used to manage loops in my network. But indeed, SNMP is something you would use to manage devices and their configurations, or to read a configuration or a status from a device. It's not used to prevent loops. It's used for you to be able to get a high-level view, or at least sometimes a detailed level view of how devices are performing. So that's one of those that really makes it easy to go through and understand those pieces. All right, we're swimming now. Those of you in the chat room, thanks for your comments and following along. Those of you have said, I don't know what BPDU is. I've never heard of that before. Now you have, and now you'll be able to answer these questions on your exam if it comes up. All right, how about another question then? Let's keep going. Which of these devices can separate broadcast domains? Well, since we're sort of sticking here on the network topology side, I thought I would give you a network topology question, which deals specifically with broadcast domains. One of the objectives in the Network Plus certification, if you haven't downloaded the objectives, you should absolutely go out to the CompTIA website and download the objectives. They are amazingly detailed. They will tell you everything you would ever need to know for the exam. And one of the topics on the exam is understanding the differences between a broadcast domain and a collision domain. And this comes up often, most often these days, in the idea of wired versus wireless. But it used to be wired versus wired. We would have broadcast domains and collision domains. And on some networks, maybe there isn't somewhere you do have a collision domain. I wouldn't think on a wired network anymore that anyone has any more collision domains. But certainly on the wireless side, common part of life, just normal for what we do with that. But you may want to separate out your network so that only broadcast domains would be within certain areas. So you can separate out, instead of having an enormous broadcast domain for your entire network, how could you split it up into smaller versions of this? And you would use one of these options. You would use a hub, a router, a switch, or a bridge. So it's going to be one of these to be able to separate out. I guess you could, in this case, choose all that apply in this particular link. You've got that option within here. You want to be able to really understand broadcast domains and how they're separated out. So once you know what a broadcast is and you know how to stop it, then you'll know that you'll use a hub, a router, a switch, or a bridge to do this. Don't answer in the chat room to be able to do that. But we've got a number of options here. Again, in this particular case, I think we've got a mixture of different things. We've got 56% have said router, 3% said hub. That one popped up. 26% have said switch, and 15% have said bridge. So we've got a mixture of different things. It would be interesting to know what these broadcast domains really are. This really applies mostly to our Ethernet networks, and in some cases IP version 4 networks as well. Broadcast domains are a way for one device on the network to send a message that everybody on the network would see. Instead of sending individual messages to everybody on the network, let's just send one packet out, and that packet goes to everybody. Or in the case, if it's Ethernet broadcast, one frame goes out and it goes to everybody. And you'll see this very common if you capture traffic on your network. You'll see ARP messages go back and forth that use these broadcasts. You'll be able to look at operating systems will sometimes send out messages as a broadcast. Now imagine if you've got 20 devices on your network, you may not even know these broadcasts are there. If you have 200, you might be noticing there's a large amount of broadcasts on your network. If you put 2,000 people on the same network, you're going to see a lot of broadcast traffic, so much that it might even interfere with the normal traffic on your network. So splitting up these broadcast domains can be pretty important to make that happen. Broadcast domains are stopped or limited by things that are a layer 3 device like a router. If you have a switch passes the broadcast right through. A switch, of course, I mentioned earlier, switches and bridges are the same thing. The bridge is kind of the old school name for it. We came up with new ways of doing this, but a switch is effectively exactly the same thing as a bridge with a lot more interfaces on it. So if you're somebody who said, well, what is stopping? I guess we can't even see the question on here. Which of these devices can separate broadcast domains? If you chose B, router, you would be absolutely correct, because that's what's going to stop this from occurring. If we were to look at a picture of the way this would work, one broadcast domain, we've got a switch in the middle of the picture here, and you can even have multiple broadcast domains, but notice we're separating them out by putting a router in the middle. The switch pictures generally have arrows that are horizontal to each other. When we have arrows pointing every direction, that signifies a router. And that's exactly the device you need to think about when you want to separate out your broadcast domains. All right, more questions. Let's keep this party going. Kind of hard to even see that one, isn't it? You need to allow terminal sessions through your firewall, but only if these sessions are encrypted. So which ports would you need to open? I get a lot of questions about ports on the exam. How do I memorize all these different port numbers that are there? And it can be a challenge. If you've never worked with a firewall before, you've never gotten into the configuration of firewalls or understanding what they are, then there's a lot of port numbers. I think a lot of people make the mistake, though, of grabbing a list of port numbers from the internet somewhere, and they suddenly see hundreds and hundreds and hundreds of well-known port numbers. For your Network Plus exam, I think you need to know about 12. So it's not an enormous thing. And in fact, you probably will recognize some of them. So you don't even need to memorize generally all 12 of them, because some of them you know. There is a lot to go through with port numbers. So go to your Network Plus objectives, and you'll be able to see if it's one of these answers. To allow terminal sessions through your firewall, but only those sessions that are encrypted. This is only if those sessions are encrypted. Oof. Which ports should you open? Should probably spend more time writing the question, shouldn't I? You can tell I did them, though. TCP21, TCP22, TCP23, or TCP3389. Which one of these would be the right answer in our case? And we would like to go to the Socrative page and be able to answer those. I think some of you are Googling this. There's not a lot of people answering this particular question. All right, that's no Googling. We're trying to learn these. Okay, now people are starting to answer them. And again, we've got kind of a mix of different things all over the place. We've got a mixture, I guess 42% if we go with the largest number here. A lot of people said TCP22, but we really are spread across a number of these others as well. Well, if we look at the question, we need to allow terminal sessions. And first you need to know what a terminal session is. That is when you're connecting to a remote device over a terminal, over a console screen, if you will. Let's see if I can pull up a console screen. I probably have a couple running on my network. I am. So I was looking at my access log information earlier. In fact, I'll just bring up a top. Here we go. And you can see I've got a terminal screen running. It's on the background behind this is the question we were answering. I've got a terminal screen running on my screen, and it's just giving me a breakdown of what's happening on one of the Professor Messer web servers. So we can see what the status is of all of the jobs that are running on my server right now. Very low percent. I like my load averages. I like my CPU percentages. Great, I'm getting some great information there, but I want to be sure that if I'm looking at this information, that nobody on the internet can see any of this. So I want to be able to allow just the ports through that will allow an encrypted terminal session. So if we look at the different port numbers that you might run into, you might see things like this. You have things like, what are we looking at? FTP. FTP uses port 20 and port 21 for its data and its control. Well, in this particular case, that's one of those where I wouldn't have to worry about too much of this because the FTP is in the clear. That's not encrypted. That's not the one I'm looking for. Secure shell. That's what I was running, an SSH session. So you would have to know that an encrypted terminal session is an SSH session. SSH, Secure Shell, uses TCP22. Now, for those of you wondering, TCP23 is Telnet, And I don't think I had 25 on my list. I did have 3389, which is a terminal services or a remote desktop session. That's not the same as a terminal session. So you have to make sure you read those questions very carefully. That means if you answered TCP 22, you would be absolutely correct. It would not be 21. It would not be 23. It would not be 3389. We know there's FTP or part of FTP. We know we've got Telnet, which is a console session or terminal session, but it's in the clear. Well, that's not what we want. We want encrypted, and the way to do that, the default port for that using SSH is TCP port 22. Okay, well, we're moving right along now. Let's look at kind of shifting our view. Somebody in the chat room was talking earlier about DHCP. So I think I've got a DHCP question for you. Let's have a look. And the question is, what criteria is used to reserve an address in a DHCP server? So this is one where we're asking for some very interesting options within DHCP. And the idea of reserving an address may not make sense to you offhand if it's a DHCP server. And obviously, we need to understand the criteria to allow that. The options that we have available for that are here. We've got a VLAN number. Is it a MAC address? Is it a motherboard serial number? Or is it an operating system license key? One of these criteria can be used in a DHCP server to reserve an address. So again, there's multiple steps here. We have to understand DHCP. We have to understand the idea of reserving an address. And ultimately, we need to understand what criteria is used. We have to type something into the DHCP server to say, this is a unique device, and I would like to be able then to have this unique device have a reserved IP address. I've probably said too much. No answering in the chat room, but of course you can go to socrative.com and go to the Professor Messer room to answer some of this. One of the things about DHCP is it's many and varied. There's a lot of administration. In fact, entire companies have been built around making the DHCP process easier. I guess maybe that means we didn't do a very good job at making DHCP easy to begin with. But we do need to think about how DHCP works and the information that's transferred back and forth to be able to see those things. This is where we really get into understanding DHCP at an administrative level. If you're managing a DHCP server, entirely possible. If you're working on your Network Plus certification, then you're really going to want to do something like that to be able to make that happen. This is one where whenever I start looking at and understanding how my system works, I'm going to want to break down DHCP in its best possible way. So in this case, I didn't fool anybody. Everybody knows that if you don't have an IP address, then you certainly have a MAC address. And that is a great way to define a very specific machine, because a MAC address, ideally, is a unique thing. Nobody else in your organization is going to share the same MAC address. Everybody has a different MAC address. The only time there's ever been a case where a MAC address has been duplicated is where you are assigning the MAC addresses yourself, which you can do on a number of network drivers, or there was a mistake at the factory and they burned in the same MAC address to the same cards, which does sometimes happen when you start getting into that. There is quite a bit that you would consider when trying to determine what device that would be, but MAC address is the way to do it. When you start setting reservations with DHCP, here's a good example, and this is my basic home office device. Of course, when you get into other DHCP servers, they work in a similar way, and you can set up an address reservation. You can see them at the bottom. And in my address reservation says that if my device shows up that has this MAC address, assign it this IP address. If it shows up with this second MAC address, assign it this IP address. That way you can get around having to do any static addressing of devices. And if you do need to make a change to your IP addressing scheme, you simply go to your DHCP server. You don't have to go anywhere else to make that particular change on your devices. You don't have to go to every individual server and change the static IP. Nobody wants to do that. Instead, you go to one central place to make that happen. That's a much better way to do a best practice for this particular piece. So that wasn't bad. That was pretty good at being able to understand DHCP and how that works. And I think as we get into understanding more about these technologies and where they come from, that's a really good thing to consider. Is DHCP isn't just dynamic addresses. DHCP is also automated addresses as well. Well, there's a number of things that you might consider if you're getting into the Network Plus certification and you're working with things like the Network Plus performance-based questions. You know, the exam itself is more than just a set of multiple choice questions. We have to do things on the exam now. You may have to go out to a command prompt and be able to type into that command prompt a number of different things. And if you've never worked at the command prompt, especially doing networking type of things before, you may realize that you need some more help. But setting up your own lab at your house or even at school can require a lot of different devices. You have to have different operating systems and different machines and routers and switches, but it may be just as easy to do something virtually in the cloud where the routers and switches are already set up for you, where the labs are already there and available for you. All you have to do is show up and go through the labs, and they're all right there on the screen waiting for you to take advantage of those. This is something from GTS Learning and their live labs, and being able to step through this is a real-time interactive view of running labs right there on the screen. In fact, I've got one running right here. Well, not right there. Not right there. Right there. There we go. Now we're on my screen. Here, in fact, are the labs. Kind of hard to see. They've got ARP and packet analysis. There's configuring DHCP servers and clients. Well, we were just looking at that, so I'm going to click on that one. All the labs are on the left side of the screen, or the right side of the screen, and on the left side are the devices. So you can click on each one of these. This one has a server, has a client. I'm going to power all these up. Has a gateway. There's a router involved and a Linux device that we can even send information back and forth. So I've essentially gone to my lab now and turned on 5 devices, as if you walked into a room and physically turned the switch on all 5 of those devices. And the labs that are here take me through step by step, configuring a DHCP server and talking about scopes. And it takes me even through the screenshots of each one of those. There's a lot of detail here to go through. When I start working with all these and start going through and understanding how am I going to make all of these things work, this is exactly how I'm going to do it. And it's using the technology in your browser. You don't have to load any additional software to make this happen. So if I wanted to, I think the gateway doesn't have much for me to connect to. There it is. I'm connected to the gateway, which happens to be a Windows device. Here, in fact, it's running Wireshark. I can run Wireshark on this device. Look how fast that runs. I can, there's the server configuration for this. Let's look at the Wireshark that's running. There it is. Let's capture some packets on this lab. I've got a number of options available. We're just going to start a new live capture. Oh, I didn't choose an interface. Let's choose an interface. That one looks good. Let's start packet captures from that. In the meantime, my server is started up, and now I can start going through my lab step by step and understanding exactly what's there. Maybe this is something you would like to try yourself. If you're looking for hands-on, that's hands-on. You don't get any better than that. In fact, most of the time when you're working on your network, you're not working in the same room as your switches and your routers and your servers. Those are in a different room, in many cases, a different building in a different city. So being able to operate and use all of these things, it's as if you're sitting right in front of those devices. This is a great way to do it. If you want to see if this works for you, you've got a free hour. You can take advantage of this. Go out to professormesser.com/netlabs, and not only do you get a free hour, but instead of paying the $159 you would normally pay, I get a special price from GTS Learning of $99, and you can make the decision on whether this particular type of front end and running through these labs works for you. And we want to thank the folks at GTS Learning also for sponsoring what we're doing during our study group as well. Great folks. I've been sitting in their building in London and talking with those. I talk to them every week back and forth, and it's a great group of people to work with. So something for you to try. They are at, what was the name? At professormesser.com/netlabs for those of you that are asking there in the chat room. So very, very useful to have that there. There's a number of things that we also want to think about when we're looking at a network. Since we're talking about DHCP, let's go to this question, IP addresses. Now we're getting away from DHCP in this case because I'm asking the question of which of these would be a best practice before statically assigning an IP address to a device. So we're getting into this scenario where I want to be able to maybe not set something like a DHCP. I am setting these statically, and I've got a number of options. So before I start using an IP address that I'm setting statically, do I Check the routing table for the address. Do I convert the IP address to a CIDR block notation? Do I determine the network address based on the IP address and the subnet mask, or do I ping the address? One of these would be a really good idea when I'm starting to assign a new IP address to a device. Maybe you've brought in a new laptop. You want to give it a very specific IP address. Maybe you've built your own management workstation and maybe you don't have a DHCP server or you don't want to reserve it in the DHCP server. You just want to configure it statically right now. I need to perform a particular function before I set that static address. Maybe you're setting up a new router or a new switch and you're giving it a management IP address. You want to be able to set that management IP address and do it in the right way, in the best possible way. So go out to socrative.com and be able to answer this piece. If you've been working with networks for any amount of time, this particular answer may be relatively obvious to you, because getting into a network and setting the wrong IP address or accidentally duplicating an IP address can be a big problem. We don't want to run into those scenarios. And I think that's why about 62% of you so far have said ping the address, which would be absolutely the first thing you should consider doing. Once you figure out what address you're going to use, let's see if anybody else is using it. That's one of the best ways to determine if an address is in use. Now, granted, a ping is not something that every device on the network responds to these days, but as a best practice, you should certainly give it a shot. See if anybody responds back. At a very bare minimum, if you get an ARP response back from a device, you'll know that something out there responded to an ARP for that IP address. So that can be very, very useful to be able to have that happen. There is very often when we're setting up static addresses is where we make mistakes. So we want to be very careful with that. If we start looking at the IP addresses and what we have there, there's a number of troubleshooting steps we should go through. One is to check your IP addressing. Make sure if we're trying to troubleshoot a duplicate IP, maybe we typed in the wrong thing. Whenever I put in a set of IP addresses into a device, I always take a moment and read what I've typed to make sure it's there. If somebody else is typing, before we hit OK, I say, let's go through it. Let's check these numbers real quick. I have 192.68.10.10. Is that what you have? Yep, 10. Oh, no, I did 10.100. Sorry. Let's fix that, 10.10. And we might have solved a problem that we had before we even had it create any issues for us. Ping the IP address before static addressing. See if it responds. Determine the IP address based on the ping. We can have a look at the ARP table and see if we can find that address. If we do have duplicates, we want to know where the duplicates are coming from. It should be easy to find in things like the tables that are on our switch. And capture the DHCP process. Do a packet capture. See where these DHCP servers are that are responding. If we're doing DHCP and getting duplicate addresses, one of these servers might be messed up. So very useful to have that there and be able to work with it. I think that's simple troubleshooting of duplicate IP addresses, and part of the Network Plus certification objectives is to be able to troubleshoot an IP address duplication. And here are 4 good steps you can use, whether you are statically addressing or in some cases using DHCP to troubleshoot those particular pieces. There is another question I have for you about WAN technologies. We talked earlier about routing technologies, but I have one specifically for wide area networks. And the question is, let's have a look. Which WAN technology pushes and pops? That's the question. It's nothing more than that. Again, no answering in the chat room. There's one WAN technology on this list that pushes and pops. That sounds like one of those dance moves from the 80s. The push and the pop. We've got ATM, we've got WiMAX, we've got MPLS, we've got PPP. Nope, I don't see any old dance moves in here at all. This must be a legitimate question about WANs, and we're using the term push and pop. We actually do. There's one WAN technology where those two methods are used to make the whole thing work. And when you start looking at WAN technologies stay around for a very long time. When you start looking at them, they're there for a long time. When you implement a WAN, it tends to stay in place for a number of years and then some. And if it's working, why would you change it? Why would you modify the WAN that is there and being able to make that happen? So these technologies and the way they operate are something that you're going to have to troubleshoot, and you're going to have to troubleshoot them for a very, very, very long time. This is where you get into pushing and popping, because one of these WAN technologies is about pushing and popping. Is it ATM? Is it WiMAX? Is it MPLS? Which one is it? Is it PPP? One of those technologies is, and the way that WANs work can be a bit of a challenge. And when we start looking at the answers that we put here, kind of all over the place on this one too. I don't know. It gives me just a little bit of happiness when there's that many people trying to figure out what that piece is. It gives us an opportunity to learn something. We'll say it that way. This is, if we want to go right to the answer of this particular question, the actual answer is something called multi-protocol label switching. This is an interesting WAN technology, in fact. It's a WAN technology that took a lot from ATM, took a lot from frame relay, and it took the best things and it got rid of some of the worst things about those technologies. This is something that is really being deployed right now. You can consider this a relatively modern WAN technology because it's one that people are actively implementing in a number of locations. This is something also you're going to find in a lot of places wherever you go. Wherever you end up, you go from one position to another, one company to another, you're going to find that somewhere there's going to be an MPLS network. And it uses this terminology of pushing and popping. As we're putting things onto this wide area network, this MPLS network, you push the packets with labels. You push labels onto these as they go through. So you push an MPLS label and you stick it into the MPLS cloud. That tells it where it's going to go. And it goes through a number of switches that are in the cloud, these MPLS routers, these routing devices that are in the cloud. You don't know where it goes. It's in the cloud. In this particular picture, I created a number of routers within it, but in reality, most providers' MPLS networks are extremely complex with multiple connections and plenty of redundancy. You've got, if you lose part of one network, everybody falls over to the other. In this case, I built a straight line just for the sake of brevity. So we insert the label, we push the label onto the packet, it goes to the other side where it is then popped off when we get it there. Now, this is kind of a shortcut term we use for encapsulation and de-encapsulation, except we're not really encapsulating in this case, really kind of sticking it into the middle of our frame and we're sending it along the way. So that's why we use that term pushing and popping, not quite the same thing as encapsulation, but does a similar function. If you want to look at it that way. Very interesting what you can see from an MPLS decode. If you want to pull that up into Wireshark and have a look at it, you see a lot of interesting things associated with that. That might be a good opportunity for us to learn more about the way things work. I highly recommend that. If you haven't been using Wireshark, you can learn so much about the OSI model. You can learn about the way these protocols work. You understand exactly what's going on as things go across the network. That's where I learned almost everything about networking was down at the protocol level because you really understand it from the bottom up, and it really solidifies things on the screen for you when you're starting to see this technology right in front of you and you can watch the conversations occur. Quite remarkable. So download Wireshark, try it out. You'll be amazed. Okay, another question for you. More about protocols. Got a lot of protocols this month. Which of these protocols would be the best choice for forwarding log information? Would it be syslog, SNMP, Radius, MSlog, or OSPF? We've got a number of options available. So go out to your Socrative page and determine which of these protocols would be the best choice. Syslog, SNMP, Radius, MSlog, or OSPF. Number of these we've talked about today. Number of these we haven't. Some of these are real. Some of these, I think at least one of these isn't. So there's a little hint for you, for those of you looking at how we do that particular piece, being able to make that happen. This is one of those where when we start getting into the higher end part of networking, a lot of what we think about doing networks is working on switches and working on routers. But there's an amazing wealth of information in the logs. And if you have multiple switches and multiple routers and firewalls and intrusion prevention systems and all of these other things that connect to the network, it might be nice to consolidate all of these logs in one place. That just makes perfect sense. Why would you want to log into every individual device? And plus, if you have all these logs in one place, I can present very nice reports of how things have been going overall. I can start correlating information in the logs together, especially if everything is synchronized over NTP, the time protocol, the network time protocol. What a great way to have an exact representation of what happened when Everything is synchronized, and I can really get a nice breakdown of what's going on. So make sure you go out to Socrative and be able to answer that question. We're going to see what people have said about this one, and got kind of a mixed answer on this one as well. We've had 35% have said syslog, 39% said SNMP, 6% said radius, 13% said mslog, and 6%, now 9% said OSPF. So which one of these would it be? We're talking specifically about forwarding, not just statistics. We're very specific. We're talking about forwarding logs. And in that particular case, we want to use a protocol called syslog. This is a standard way of transferring log information. Now, what's in the log isn't standardized. As you can imagine, routers have their own log format, switches have their own log format, but at least there's a standard way to transfer that information back and forth. This centralized log server is usually a very big device. It's able to handle not just a lot of processing, but it usually has a lot of drive space available, so you can store all these logs over a very long period of time. And if you have a log consolidation device, it's almost always going to do some type of reporting for you because it's storing all this information. What a great place to go through and store that. So although SNMP is something that we can query a device and get real-time statistics about how that device is running, those aren't logs. Those are statistics. That is Simple Network Management Protocol. It's managing the device. The standard way to transfer logs is with syslog. So if you answered A, that would be correct. Radius is a standard way for doing authentication on a network so that you can log in one place and get access to all the things you might need. That's one way to use Radius. OSPF, as we've discussed already, is a dynamic routing protocol. So OSPF, that's not really what we're looking for. And MSlog, I just made up. Just fake thing. It has log in the name. It has MS. That's Microsoft. So sounds like that would be right. Sounds exactly correct, but it's not exactly right. And indeed, I do say syslog is a protocol. Syslog is a standard way of communicating back and forth. It is a protocol communicating across the network for those of you in the chat room. It is absolutely a way to do that. Now, remember, we're not talking about layers at MAC addresses or IP addresses. This is well within the IP part of the packet. And the standard format, it's a standard format for doing this that does absolutely qualify it as a standard protocol. What a great way to do that. Now, for those of you, as I mentioned earlier, go out, grab your Network Plus certification objectives. Go out to CompTIA or go out to the Google and type in CompTIA Network Plus objectives. It will take you right to the page. You can also go to professormesser.com/objectives. Already got that for you. So that will take you. Just type in professormesser.com/something. And occasionally it takes you somewhere interesting. So /objectives takes you to the objectives page. And you'll be able to go to that objectives page and be able to download, because there's a ton of information in there. Don't forget to do that. It hurts me when people show up in the chat room. They say, I didn't do well on my exam. What happened? I said, well, what part of the objectives was throwing you off? What objectives? I don't know what you're talking about. You got to have the objectives. They are detailed. They will tell you everything you need to know. They're a great checklist if you want to be able to do that as well. Well, the last question of the day is, I want to know what you would like to do next time. So if you're watching us live, you can answer this. If you're not watching us live, unfortunately, you can't answer on Socrative, but you can absolutely go to the Professor Messer website anytime during the month. There is a contact us right at the top of the page. Contact us really contacts me, goes right to my mobile device, goes right to my phone. I get to read all your messages that are coming through and be able to see those pieces right there. And it's a good way, of course, to tell me what you would like questions about so I can answer. I think we had a good mix in this particular case. I can ask things of you to be able to see that. So some of you said protocols, a lot more port questions. I agree. The security is a big part of the exam. So getting into firewalls and security is a big section. So we want to do that. Routed versus non-routed protocols. The SOHO wireless, there's some questions about that. Subnetting. A lot of you ask about subnetting and try to fit fundamentals of subnetting into this. And I keep saying that we're going to do one where we're doing all about subnetting. And I keep coming off of that a little bit and being able to make that happen. Be able to have those pieces there. So I will have all of those things summarized on the screen. I'm going to leave this question up for a little bit during the after show so I can collect all of your responses and have those all available. I get to see all of those as they're coming through and being able to work with those pieces. So make sure you take advantage of that. Well, we've gone well over an hour now. We went through quite a bit. Remember that my Network Plus study guide can be found at professormesser.com/netsg. If you'd like to just follow what we do throughout the week, I do have all the links there, professormesser.com/Twitter/YouTube/Google+/Facebook. I'm on all those. I try to get information onto those as much as possible. If you wanted to do one thing today to help contribute to what we're doing on the site, go to YouTube, subscribe to my YouTube page. It is remarkable how important that is and the types of things I'm able to do, like this live event, just because you're nice enough to subscribe to my YouTube channel. It's hard to, we'd have a big conversation. We have to sit down and have a number of drinks, and I could tell you all kinds of interesting stories about the industry and the way it works that way. Again, thanks to GTS Learning. If you'd like to try your free hour of your live labs and try this yourself, see if it's something that might work for you, go out to professormesser.com/netlabs and give that a shot. And of course, thanks to you. We would not be able to do this study group if I didn't have your support and your questions and be able to sit here and have the chat room razzing me as we go through the entire piece of it. It just wouldn't be the same. Thanks everyone for joining us. We'll see you next time on the Professor Messer Network Plus Study Group.